What's up, Math 1? This is Mr. Bainey. This lesson is 11.3, Solving Linear Systems by Adding or Subtracting. So how can you solve a system of linear equations by adding or subtracting? Also known as elimination. And this is the third and final method to solving a system. Remember, the first two methods were graphing and substitution. I'm going to go straight to some examples for us to try out. On the second page of the lesson, you're going to see some steps to how this elimination method works. Remember, it's also called adding or subtracting because that's essentially what we're doing. We're adding everything straight down or we're subtracting. And you do have to figure out which one you have to do, add or subtract. On page 505, let's take a look at number 5. So if I add everything straight down, keeping in mind that I can only combine like terms, but this is set up very nicely. These are both in standard form. You can see my x term and my x term are lined up. My y term and my y term, other y term are lined up. I got my equal signs lined up, and then my constant terms also lined up. So if I add everything straight down, let's see what happens. 2x plus 3x is 5x. And by the way, I forgot to mention, I am adding and not subtracting because it does tell you to do adding or subtracting in the directions. I need to add because you're going to see that if I have a positive 5y and a negative 5y, I add those. I add a positive 5 plus a negative 5 to equal a 0, and that's why I've circled it. And that's going to equal negative 24 plus 14, which is negative 10. And if I divide by 5 on both sides, we get our solution for x. And of course, we have to figure out what y is. So I'm going to use the first equation. Instead of 2 times x, it's 2 times negative 2. And solve for y. I'm going to add 4 to both sides, get negative 20, and there's our y. That means these two lines, if they were graphed, would intersect at this point. Okay. Pay very, very close attention to the reason why I added, because a lot of the mistakes will come from you choosing the wrong operation. If you're thinking subtract, just because this is a subtraction right here below, so you're subtracting 5y, you will also subtract these other ones, and that will lead you to the incorrect answer. Number 6, I'm going to start you off on this. I'm going to pause it, and I'll ask that you pause it before the solution pops up in front of you. So 3x and x don't have the same number, which means if I add or subtract these, it's not 0. Remember, we call it elimination because we're really getting a 0 with the x's or with the y's. Over here, we got it with the y's. And again, we're going to make a 0 with our y terms. So we have a positive 2y and a positive 2y. If we want a 0 with those, well, both positive, we need to subtract those. So you're also subtracting down for the x terms, and we're subtracting for our constant terms. Okay, go ahead and pause it. Solution will be up in a few seconds. Here's the solution for number 6. I subtracted straight down and ended up with 2x because I subtracted 3x minus x. 5 minus negative 1, I will see some mistakes sometimes from some of you on this. So, make sure it's minus a negative, which is the same as a plus 1. Gives us a 6. You go through, you follow the same process as the other your turn, number 5. Now we're going to take a look at what happens when we don't have a solution, don't have a point where they intersect. So on number 7, I'm going to do that one, and then I'll ask that you pause it to try number 8 in a moment. The 4x and the 4x right here, they're both positive. If I want to eliminate, make a 0 with the x terms, I subtract, which means I subtract here and I subtract here. So 4x minus 4x is 0. Now, negative y minus negative y also gives us a 0. My equal sign is right after that. So I only have 0 on that left side. And then 3 minus negative 2 is like 3 plus 2. That's 5. If you watched the video from my last lesson, 11.2, we did special cases like this. When we end up with the false statement, that means no solution. And graphically, that means that they're parallel lines, because no solution means they don't intersect anywhere. And the only time that happens for straight lines is if they're parallel. Okay, go and try number 8. Pause it. Solution will be up in a few seconds. As you can see for number 8, I added straight down because I have a positive x and a negative x. So positive x plus negative x gives me that 0. Negative 6y plus positive 6y, also 0. And after the equal sign, 7 plus negative 7 is 0. And I end up with my true statement of 0 equals 0. And remember that a true statement that we end up with when we use either substitution or elimination means that there are infinitely many solutions on a graph. They are both the same line. They overlap each other perfectly. Okay, so they intersect everywhere. Let's take a look at a word problem. On page 508, number 9, the perimeter of a rectangular picture frame is 62 inches. Difference of the length of the frame and twice its width is 1. The system of equations represents a situation where L represents the length in inches, W represents the width in inches. What are the length and width of the frame? So what's nice here is that they actually give you the system. The perimeter of a rectangular picture frame is 62 inches. That's the first equation, because perimeter is 2L plus 2W, 2 length plus 2 width, and it tells you the perimeter is 62. Then it says the difference in length of the frame, that's L, and twice its width, which is 2W, is 1. So difference means we're subtracting. Difference between length and twice its width equals 1. Let's solve this. We have 2L plus 2W equals 62. I'm rewriting it so that I can use my elimination method. L minus 2W equals 1. I am looking at my W terms and seeing that they both have a 2 in front of it. One's a positive 2, one's a negative 2. And I know that if I add them, add positive 2 plus negative 2, that will become 0, which means I need to add everything else. I get 3L equals 63, which means my length is 21. And this is in inches. What's important is, since we're in a context, we need to make sure our answers make sense and that we're including the units. Very, very important. If the length is 21 inches, what's the width? And let's use the second equation. So instead of L minus 2W, it's going to be 21 minus 2W equals 1. If I subtract 21 on both sides, I get negative 20 and divide by negative 2 to give us 10 inches for the width. There you have it. That's it for this lesson. Thank you so much for watching. I hope it was helpful. Have a great day.